Welcome everybody. Today we are studying about concept of ratio from chapter ratio and proportion. Actually, what do you mean by ratio? To clear this concept, let's see some slides here. Look at these pictures, their height, their dimensions. You have to compare them and think about their size and their heights. Some pictures are big, some pictures are small. That means, how can you compare? You have to first think about it. Now we will see the another slide here. In this slide, you have some cubes as well as cuboids also. In the picture, there is a chalk, pencil, as well as eraser and pencil. In next slide, we will see the measures of these pictures. See, in figure 1, the length of chalk is 4 centimeter and that of pencil is 12 centimeter. In figure 2, length of eraser is 3 centimeter and length of pencil is 12 centimeter. In figure 3, you are given the height of the fort is a 20 meter and height of that wall is 5 meter. At the beneath, there is a two circles of radii 6 centimeter and 3 centimeter respectively. You have to compare them in comparison between the chalk as well as pencil, eraser and a pencil, height of a fort and height of a compound wall, and radii of both circles. Now we will see the another slide here. In these pictures, we are given volume of first cuboid V1, volume of second cuboid V2, as well as volume of cube V3 and volume of cube V4. How will you compare them? Either by subtraction method or by multiple. In comparison, by subtraction, we can say that the length of pencil is 8 centimeter more than the length of chalk. Or by multiple, we can say that the pencil is 3 times more than the or longer than the chalk. Such type of a comparisons you have to find here. If you compare the volume of cuboid, we can say volume of first cube is 56 cubic centimeter more than the volume of V1. Or by multiple, we can say that volume of first cuboid, that's V1, is 8 times more than the volume of cuboid V2. Similarly, you have to compare the volume of cuboid. Ratio is also a type of comparison. Now, to clear the concept of ratio, how to write them, how to consider, how to understand this, we can see the further slide now. Comparison can be made by subtraction method or a division method. Comparatively, whenever we can say that the length of any object is how long as compared to the another. Just in the first figure, we have seen that the length of pencil was 8 centimeter more long than the chalk. We have seen the volume of a first cuboid, it was 56 cubic centimeter more than the second volume of cuboid V2. Another method we can compare it by the division method. That means multiply. As an example, the length of pencil is 3 times more than the length of that of the chalk. But it will be so difficult many times to write or to understand by simple method. We have to understand their relations, lengthwise say, or by volume wise. There is a simple method of a ratio to understand the comparison between two objects, and it will be useful for finding the other ratios also. Now we'll see the another slide here. See now, the ratio of height of chalk and a pencil, it can be written as H2 is to H1. Listen, first we have taken the height of chalk, that's H2, and the second is the height of pencil, it is denoted by H1, and the ratio is written in the form of two dots in between them, that's H2 is to H1. Their values are kept here, 4 and 12, that's 4 is to 12. Actually, this ratio is said to be as like a division. It can be written in the form of a fraction. It's a 4 upon 12. And if you reduce it or divided by the number 4, we will get the reduced value again, 1 upon 3, and it can be written as 1 is to 3. Second example we can see here, the height of a pencil and height of a chalk. That's again given H1 is to H2. H1 is the height of a pencil, 12 centimeter, and height of a chalk, eraser. That's chalk. It is 4. That means while writing the ratios, you can use first object first or second object also first. This second example you have written H2 is to H1, that's a 12 is to 4. Again it is written in the form of a fraction, 12 upon 4. We can divide it, 12 and 4, by number 4, and the reduced value is 3 upon 1, and it can be written as 3 is to 1. Now in another next example, see, there is a ratio of pencil to the eraser. Height of a pencil H1 and height of a eraser is H2. This 3 is to 12. Again, reduce it, dividing by 3, we will get 4 upon 1, and the ratio of height of pencil and eraser is 4 is to 1. Last example here, ratio of height of eraser and a pencil. First time we have taken the ratio of height of pencil with the eraser. Now we are taking the ratio of height of eraser with pencil, and therefore it's written as H2 is to H1, and put the values here. It's a 12 is to 3, write in the form of a fraction, 3 upon 12. Again reduce it by dividing 3, we'll get 1 upon 4, and the last is ratio is 1 is to 4. Now again see the further. We have given here two circles, their radii. Radii of a first circle R1 is a 6 centimeter, and radius of a second circle is 3 centimeter. Then we can write the ratio of radii of a first circle to the radii of a second circle, that's R1 is to R2. Put the value here, 6 is to 3. It can be written in the form of a fraction. It's a 6 upon 3, reduces by dividing 3, we will get 2 upon 1, and the last ratio will get 2 is to 1. Now ratio of R2 means radius of second circle to the radius of first circle, that's R2 is to R1, is equals to, put the value here, 3 is to 6. It's written in the form of a fraction is 3 upon 6, divided by 3 to both numerator and denominator, we will get 1 upon 2, and the reduced fraction is 1 is to 2. Similarly, there is given the height of a fort and height of a wall. Now we will see the ratio of height of fort to the height of wall. That's height of fort is 20 meter and height of wall is 5 meter. The ratio will be 20 is to 5. It can be written as 20 upon 5. Divide both the numerator and denominator by 5. We will get the reduced value 4 upon 1. And it is written as 4 is to 1. And then last ratio there is again height of a wall to the height of a fort. It can be written as 5 is to 20. Again 5 upon 20. Reduce it by dividing 5. You will get a reduced value 1 upon 4, and the reduced ratio will be 1 is to 4. This is the simplest way to find the ratios between the two objects. That means we can compare them or compare the two objects, how long or how much smaller the object they are here. Another one, you are given the ratios of volume of cubes. See in the example, the volume of first cube is a V1. It is 729 cubic centimeter, and volume of another cube is 216 cubic centimeter. Then how will you write the ratios of their volumes? Ratio of volume of cubes, that's the V1 is to V2. Put the values. 729 is to 216. Write in the form of a fraction. Reduce them by dividing the common number, and we will get the last value 27 upon 8, and the ratio of volume of first cube with the second cube is 27 is to 8. Now see another example here. We are interchanging them. That means writing the ratio of small cube, volume of a small cube to the volume of a big cube. That ratio is written as V2 is to V1. Put the values there. 216 is to 729. Write in the form of a fraction. 216 upon 729. Reduce it by a common number, and you will get reduced form 8 upon 27, and therefore the ratio of volume of small cube to the big cube is 8 is to 27. Similarly, you are given the height of big cube and a height of a small cube. We can find the ratio of these sides also. The ratio of sides of cubes, that's S1 is the side of big cube, and S2 is the side of second cube. Therefore, we have written here S1 is to S2, that's equals to, put their length here, 9 is to 6. Then write in the form of a fraction, 9 upon 6. Reduce it by a common number. You will get the reduced value 3 upon 2, and that's equals to 3 is to 2. That means the ratio of sides of these cubes are 3 is to 2. Similarly, we can interchange them. That means sides of small cube to the side of large cube. It can be written as S2 is to S1. Put the value 6 is to 9. We will get 6 upon 9. Reduces, and the reduced value is 2 upon 3. That is written as 2 is to 3. That means we can compare the length of the cubes in which ratio they are. It will be easy to understand and easy to write also. Now, you have this ratio shows how many times the other object is. In first ratio shows the chalk is 1/4 shorter than that of the pencil. That of the second shows pencil is 4 times bigger than the chalk. First I have explained it. Third ratio shows comparison between eraser and pencil. What it will be? You have to think. Yes, think. The comparison between eraser and a pencil. You have to find. It will be what it will be. Eraser is 3 centimeter long and pencil was 12 centimeter. That means we can say that eraser is shorter. How many? 1/3 times shorter than the pencil. Can you compare the height of a board and a wall? Similarly, you can write the comparison, you can find the comparison with the help of the ratios. You have some examples here. You have to find the values or reduced form of the given ratios. 15 and 20. You have to find the ratio of first number to the second number. First number is 15 and 20. Similarly, you have the examples like that. Find the ratio of second number to the first number also. You have to find the values or reduced form of the given examples. See, what you will write here for first example is a 15 and 20. You can write first number is a 15 and second number is a 20. Therefore, we can write it 15 is to 20. 15 and 20 is divided by the common number 5. 5 3 the 15 and 5 4 the 20. The reduced form will be 3 is to 4. Similarly, you can solve the another examples. In second, you have to find the ratio of second number to the first number. That means while writing the ratio, you have to write second number first. That's the 35, and first number 25 will be later. The ratio will be 35 is to 25. These two numbers are divisible by 5. Therefore, you can divide by 5 both of them. 5 7 is 35 and 5 5 is 25. The reduced form will be 7 is to 5. Guys, similarly, you can find the ratios of remaining examples. Some solved examples are here. Now, see the example here given below. Write simplest form of these ratios and find conclusion. Let's see. The first ratio 1 is to 3. By simplifying them, it can be as it is, that is 1 upon 3 is equals to 1 is to 3. In second example, 9 is to 27, that's equals to 9 upon 27. Divide numerator and a denominator by 9, you will get the reduced value 1 upon 3, and again the ratio of that number is 1 is to 3. Similarly, in a third example, we have 11 is to 33. That 11 upon 33 and reduced form is 1 upon 3. Again, the ratio is 1 is to 3. In the last example, you have 15 is to 60. That again can be written as 15 upon 60. That's equals to 1 upon 4. And the ratio is 1 is to 4. What can your conclusion about these 4 examples? Above examples 1, 2 and 3 have the same reduced value, that is 1 is to 3. Such ratio are said to be equal ratios. That means there are 3 different ratios. These are 1 is to 3, 9 is to 27, 11 is to 33. But the reduced form of all these 3 examples are 1 is to 3. And therefore, such type of a 3 ratio, that means 1 is to 3, 9 is to 27 and 11 is to 33 are said to be the equal ratios. I think all guys, you can understand the concept of here equal ratio also.